Let us draw one here. Assign it a vertex, assign it this triangle versus B naught, B1. For example, okay. Now there are two ways I can orient this triangle. I can either tilt it this way. This is called clockwise, okay? Or I can tilt it the other way around. It's called counter. Also, there are two possible orientations on simplices. Number one is clockwise. Number two, I'll call it counter. Or some call it anti-clockwise. Okay. Now, as for this triangle, let us pick this one now. Supposing I take the other one, the counterclockwise, okay? I want to, the one going this way, okay? So how do we do it? I will have B naught, B1. That's the first one, isn't it? Then which one again? Plus. Because you see, the clockwise can be, I can have something like the B naught, B1, B2 in a cyclic form. Okay, this is cyclic. Meaning that this is the same as B1, B2, B0, which is also the same as B2. Sorry, I wrote 2 here. B2, B0. Yeah, they are all the same in a cyclic representation. So I'm going counterclockwise now. I'm going this way. Okay. Now, if I decide to go the other way, I will have B2, B0, B2, B1, then B2, B1, B0, then B1, B0, B2. Isn't it? That will be the clockwise. Good. Now, I will now define the boundary define as follows. The boundary of an edge in a simplex is the initial point minus the final point minus initial. Let me be using this. Let me be calling this vertex minus initial vertex. Wa alaikum salam. Oh, another way they call this one is they call it head minus tail, depending on how you want to call it. Okay. You either call it final vertex minus initial point, or you call it head minus the tail minute. So if I am taking this vertex, now suppose this is my vertex A. If I assign this A and say this is B, C then the boundary of this H, not but is final point minus initial point. Is it clear? So the boundary of A, for example, will just be B1 minus B2, isn't it? What if you are now taking the edges? You say A minus B. What is A minus boundary of A minus B? Minus, isn't it? So you say the boundary of B will be what? B2 minus, in that case it will be B2 minus. And the boundary of C will be B0. In that case, although, okay, minus of B0 minus B2. Okay, something like that. Now, but I want these boundaries, I want them to look like, I'm now taking, now, by boundary, what I mean, I'm not trying the boundary of the whole triangle, the whole simplex. And I want it to be the sum of these edges, okay? I want to define this as the sum of edges. That means A plus B, isn't it? So, and I want to say now an H, A is just B, not B1, this is just, so that means I will have it like this, B not B1 plus this one H plus B1, B2 minus B not B2. Now I'm using minus here because I have tilted this one. I'm not starting from. Is it clear? Yes. Now what we are saying is that this boundary of this simplex, this one, we say can be obtained using a formula. You have for obtaining it. And that formula says, that formula is sum t or whatever from 0 to 2, because the highest vertex you have is 2, minus 1 raised to power t. Then you now start putting back v naught dash dash out to vt. Now you put a curve, then dash dash out to v2. This formula actually is going to give you the boundary of the whole simplex. And we can try it. We say our vertex start from 0. So if t is 0, let's see what we get. You substitute in this formula. So minus 1 raised to power 0, you have minus 1 Because T is 0, you are going to omit B naught because the hat means the hat here, this hat means omit. That means without a button host. So if T is 0, I'm going to omit B0. So I will not write B0. So when I omit B0, what will I have? I have no, so no B not B0 in this, but if you omit this, you are left with what? B1, B1, isn't it? Now, so the first thing, minus 1 per 0 is 1, so it's simply B1, B2. Now, if T is equal to 1, you have minus 1 raised to power 1 is going to be minus, isn't it? So you have minus here, so minus 1 raised to power 1. You are going to write B naught, because T is 1 now, you are going to omit B1, so you write B, you omit B1. The next one will be what? B. Good. So it's going to be minus B naught. Okay. Now, if finally T is equal to 2, you will say minus 1 raised to power 2. You will write B naught, you will write B1, you will omit B2. So you are going to have minus 1 raised to power 2 is plus 1. So this is simply what? B naught B1. So if you are, because you are doing the sum, so the area, the boundary is the sum now, isn't it? So the boundary will be the sum. So I will write the first one, B1, B2, plus, the second one is plus, it's B naught, B1, minus, because plus minus is minus, B naught, B2. So this is what we should have. And I think this is the same here. B naught, B1, I have it here. B1, B2, I have it here, minus. So you can generate this from this formula. Okay. This is for triangle. You can also try the same with P2, delta 2, because that's the tetrahedron.